Hi, and welcome to Always Eclectic Stacy. This is Always Eclectic Chemistry, and today we're discussing the properties of covalent bonds and covalent compounds. Ready, set, let's get covalent! Hi, and welcome to Always Eclectic Stacy. Today we're going to be talking about covalent bondings, giving you a brief overview on the properties of covalent bonds. Why do atoms bond? Remember, they bond to get to a stable electron configuration of 8 valence electrons, which is called the noble gas configuration. They do this by either giving or taking electrons, like an ionic bond, or in a covalent bond is where atoms share electrons, so they all are at 8 valence electrons by sharing their electrons. A covalent bond is a chemical bond that results from the sharing of electrons. The shared electrons are considered to be part of both energy levels of the elements that are bonded and sharing electrons. So they kind of make a separate hybrid orbital. This occurs when elements are close together on the periodic table, and that is why covalent bonds are generally between a nonmetal and a nonmetal, although there are just a few exceptions, like with boron and aluminum. They like to share their electrons. The strength of the covalent bonds is dependent upon the distance that separated the bonded nuclei. The more they have shared electrons, the stronger of the covalent bonds, and the bond length decreases. So a single bond has a very large bond length, a double bond has a shorter bond length, and a triple bond has a very short bond length. Now, remember the two different types of reactions. An endothermic reaction occurs when a greater amount of energy is required to break existing bonds than is released when forming new bonds, and an exothermic reaction occurs when more energy is released forming new bonds than is released in breaking apart the reactants. In covalent bonds, it's really important to understand that there are some diatomic molecules. These occur in gas form, and they occur naturally because they are more stable than individual atoms. These are in gas form. So if you're reading an equation or a reaction and it says like oxygen gas or chlorine gas, it's expected that you understand that they're talking about Cl2 and N2 or O2 and not just O by itself. They're diatomic, di meaning two. And there are 7 naturally occurring diatomic elements and molecules. That is fluorine, which is F2, nitrogen, that is O2, N2, oxygen, that is O2, chlorine, which is Cl2, bromine, which is Br2, iodine, which is I2, and hydrogen, which is H2. A quick cheat sheet is here. So remember, a sigma is a single bond with 2 electrons shared. A sigma pi is a double bond with 4 electrons shared. So when we're talking about electrons shared, that's total electrons shared. So a single bond is going to have 1 electron from each element. A sigma pi is going to have 2 electrons from each element. And a sigma pi pi, or a triple bond, is going to have 3 electrons from each element for 6 total shared. So column 13 can make a covalent bond with 3 sigma bonds. Those in column 13 will not have a full octet. They are okay with 6. It is an exception. Column 14 is covalent, and it needs to make 4 bonds. So we can have 1 sigma pi pi and 1 sigma, 2 sigma pi's, 1 sigma pi, and 2 sigmas, or 4 sigma bonds. Column 15, it's going to make a 1:3 ratio with column 1, a 2:3 ratio with column 2, a 1:1 ratio with column 3, can make 1 sigma pi pi, a sigma pi, and a sigma, or 3 sigmas. Column 16, bonds in a 1:2 ratio with column 1, a 1:1 ratio with column 2, a 2:3 ratio with column 13, can make 1 sigma pi, or 2 sigmas. And column 17 can bond in a 1:1 ratio with column 1, a 2:1 ratio with column 2, a 3-to-1 ratio with column 13 and can make 1 sigma bond. Okay, now that we talked about the bonds and what they can make, let's just do a quick overview of polarity and electronegativity. I do have a very large video on that that explains in detail the differences. This is more of an overview. So polar covalent bonds are formed when there is a large difference in electronegativity, which results in the unequal sharing of electrons. When this happens, the shared electrons are going to be pulled towards one of the atoms more, and the electrons are going to spend more time around the atom with higher electronegativity than the other bond. This forms both a partial positive and a partial positive charge. The polar bonds are often called dipole bonds because you have a polar, a negative pole, and a positive pole. This is not an ionic bond where you have both a positive and a negative electron. This is going to be more positive or more negative, but it's not ionic. Nonpolar is with similar electronegativities and the charges are balanced within the VSEPR shape. And if you're wondering about VSEPR, I have an entire video on that as well. Polar is dissimilar electronegativities and charges are not balanced within the VSEPR shape. And here are some examples where you can kind of see that difference and what it might look like. A big important understanding between polar and ionic between properties is that polar and ionic molecules are both soluble in polar substances versus nonpolar substances are only soluble by nonpolar substances. So remember, like dissolves like. So if it's polar or ionic, it's going to be soluble in polar substances like water. Nonpolar substances can only be soluble in nonpolar substances. A big thing that you can think about is that salt will dissolve in water, sugar will dissolve in water, but oil and water will not mix. Okay, let's talk about some of the different properties of covalent compounds. And the differences in these properties is a result of the different attractive forces. So a covalent is a force between atoms and molecules is strong, but the attraction between individual molecules is weak. The intermolecular forces, or these are van der Waals forces. Dispersion forces, the intermolecular force between two nonpolar compounds. And we're going to go in increasing strength here. Dipole-dipole force is the intermolecular force between two polar compounds. And then a hydrogen bond. This is a bond between a hydrogen and a fluorine, oxygen, or nitrogen atom, and they're incredibly strong. We will be doing another video looking very deeply into these different forces. This is just a really good overview. And then let's talk about the properties of covalent compounds. They consist of uncharged or neutral molecules. They're usually found in both liquid or gas form, but if they're in a solid form, they're going to be soft and waxy. Please think of like the caramel on a caramel apple. It's kind of soft and waxy. It's not hard. They usually have very low melting points, with a few exceptions of the giant molecular compounds. This is why you can melt sugar to make caramel, but you don't really melt salt. They're not a conductor in all states. They're not going to conduct as a solid. They're going to be more of a conductor in the liquid state. And the solubility in water really does depend on polarity. Okay, this is a good overview of covalent compounds, their bonding potentials, and their properties. Thank you so much for watching Always Eclectic Stacy. This was Always Eclectic Chemistry. If you liked my videos, please go ahead and check out some more, and please do not forget to like and subscribe. Thank you. Have a great day.